Today we're moving on to percents of increase and decrease. This is section 6.5. So make sure that you have a piece of paper and a pencil and you're ready to take notes. Write this on the top of your paper. So the first thing that we're going to talk about is our percent of change equation. So this is the percent of change equation. So we're looking at the amount of change over the original amount. You might notice there's weird little lines on each side of the amount of change. If you remember back to probably the first chapter we went over, those are called absolute value symbols, which means that if I am taking the absolute value of -2, that's going to equal +2. If I take the absolute value of a +2, that remains a +2. So basically what that's saying is if you end up with a negative number up there, just change it so it's a positive number. If you just take the bigger amount minus the smaller amount, you're never going to get a negative. So just keep that in mind. This should be a positive answer at the end, so we're not messing with any negatives. And that's telling you to get rid of any negative if you end up with one. Another thing that you need to know before we can get started working on some problems, you have the equation, but if I give you a new amount that's greater than the original amount, that means that it's going to be an increase. If the new amount is less than the original amount, that's going to be a decrease, which is pretty basic, but you do have to identify if it is an increase or a decrease. So if we're going from 2 to 5, you can probably easily tell me that that's going to be an increase because the new amount is bigger than the old amount. If we were going from 5 to 2, though, that's going to be a decrease because it's going down in numbers. And the new amount is less than the original amount. 2 is less than 5. And so you're going to be telling me whether it's an increase or a decrease, and you're going to be telling me the percentage. And the percentage comes from that equation back over here. That's going to give us our percent. So here's some practice problems. First thing we're going to do is say whether it's increasing or decreasing. So if we're going from 10 inches to 25 inches, I know that that's going to be an increase because it goes from a smaller number to a bigger number. So that's going to be the first thing that I write down, that it is an increase. Now we have to do our percent of change equation. I know that it's going to be the change, that says change, I promise, over, we said the original amount. And so when I'm looking at this, to figure out the change just means that it's going to be a subtraction problem. So I can take 10 minus 25, or I can take 25 minus 10. The only difference in those two answers are this one is a negative 15 and this one is a positive 15. But because of what we talked about earlier, we're going to be doing the absolute value. And so that means that both of these answers are going to end up equaling 15. And so it doesn't matter which way you subtract them. I think it's a lot easier to take the bigger number minus the smaller number because then you don't have to deal with negatives. But if you forget and you do 10 minus 25, that's totally fine as well because you're still going to end up with the same answer as if you did 25 minus 10. And so that's going to be the change. That's the numerator of our problem. And then that's going to be over the original. So this one is the original because that's what we started with. And this one's going to be our new one because that's what it changed to. So 15 or 10 is going to go in our denominator. We're going to divide those two numbers. 15 divided by 10 is going to give us 1.5. Remember, this is the percent of change. Right now, this number is written as a decimal. We need to change this decimal into a percentage. To do that, we're going to multiply by 100, or we're going to move that decimal over 2 times. And so that's going to end up being 150%. So it's a 150% increase. And that's going to be our final answer there. You have to have both of those things. It doesn't matter which order they come in, but you have to have 150%, and you have to say that it is an increase. I want you to pause and try the second problem. I'm going to be going through the answer with you, but I want you to attempt it by yourself. So the first thing that you should have done is say whether it's an increase or a decrease. If we're starting at 65 and then we're going to 57 people, we can say that that is a decrease. And now we have to figure out our equation. So we know that the equation is change divided by the original. So the change is a subtraction problem. I told you earlier that it's easier to take the bigger number minus the smaller number, 57. So 65 minus 57 is going to give us the number 8. Now we have to put it over the original number. So we've already done that 65 minus 57, which gave us 8. We have to do divide by the original. Divide by the original, which was 65. We have to simplify that. So in my calculator, I'm typing 8 divided by 65, and I get a really long decimal. So what I'm going to do is I'm going to do 0 point, because that's how it starts off with, and then I'm going to write the next 3 numbers. The next 3 numbers are actually just 1, 2, 3. I know that to get to my percentage, because right now it's a decimal, I have to move over my decimal 2 points. And in this problem, I did not tell you to round it all. So you can either round to the nearest tenth, which would say 12.3%, because that's what that says. Or you can round to the nearest whole, which means you're going to be looking at this 3, and we're going to see if that 3 rounds up that 2. Since 3 is less than 5, it does not round up the 2. So you could also say 12%. So either one of these answers would be acceptable, because I did not tell you how to round your answer. And that is it. So hopefully you got one of those 2 answers and you said that it was a decrease. These next 2 problems I want you to try by yourself. Remember to say if it's increasing or decreasing, and then find the percent of change. I'll just have the answers for you when you're done, so hit pause now to try out these 2 problems and check your answer with me when you are done. And here's your 2 answers. So for number 1, you could have gotten 18.75%, 18.7 or 8%, or you could have said 19%, and then you would have had to tell me that it is also a decrease. For the second problem, you should have either gotten 85.7% or 86%, because that 7 is going to round up that 5. And you should have told me that it was an increase. Next thing I'm going to talk about is the percent of error. So percent of error is always going to be positive, just like the last one was. It's going to be the same as percent of change. It's just a different way of thinking about it. This time, though, we're not going to say it's an increase or a decrease. We're just telling me how much it was wrong. So error means something happened that was wrong, and we're going to figure out the percentage of that error. So it's going to be the amount of the error divided by the actual amount. And remember that this numerator stays positive. We do a lot of word problems with these types of equations, the percent of error equations. So our first word problem is we estimate the length of a classroom is 16 feet. So we're looking at this room, we think that it's 16 feet long, but then we actually get out a ruler and we measure it and it's 21 feet. So we have to figure out how much we were wrong by. So like our equation says, we're going to figure out the amount of error. So amount of error divided by the actual amount. And so we've got two numbers here. We've got 16 and we've got 21. You have to think which one's the actual amount. 16 was our guess. Guess. 21 is what that room's actual length is. And so 21 is our actual amount. That's what's going to go into our denominator. We have to figure out how much we were wrong by. That's going to be the amount of air. So we're taking 21 minus 16. So we were off by 5 feet. And that's going to go into our numerator because that's how much we were wrong by. Then in our calculator, we're taking 5 divided by 21. And we end up with 0.238. Again, this is a decimal. Make it into a percentage by moving over that decimal 2 times. And our amount of error was 23.8%. Or we could say that we were 24% wrong. So either one of those answers is acceptable because I did not tell you which way to write that answer. Now you are going to dive into your homework. So that's going to be page 244. You're going to do problems 10 through 15, and then 17 and 18. If you have any questions, send me an email.